object classes that were responsible for different aspects of those objects. And that actually turned out to be fairly useful, as I've said. When we'd hire new engineers, I'd go to Kinko's, get color copies, hand them, and say, this is what we're building. So architecture doesn't have to be a volume of documents. It can be a relatively small set of documents. Focus as you know, connections and subsystems. But what's important is that it has to be grounded in what the users need. And this often involves a trade-off. What's more important? Is it going to be performance? Or is it going to be completeness of representation? What's going to be more important? Is it going to be compactness, the memory footprint? Or is it going to be the amount of data that you handle? So part of architecture is deciding what the priorities are. You know, are we going to store the data so we can access it faster but have memory lookup and have to maintain large tables of data? Can it be done on a procedural basis where we can calculate the data in real time, so we're trading off processor speed for memory usage? You have the fundamental structure, environment of the solution. In other words, what are the technologies that are going to be used? Much as in the same way that, you know, designing a building, you're going to say, well, you know, the building's going to be 70 stories tall, so there are only certain materials that we can use that are strong enough to support the framework of the building, and we have to have foundation to a certain depth and so on and so forth. And so you have constraints and opportunities. And last but not least, you have to get everyone involved and on board. This gets back to Tom Anthony's comment, architecture is a political act. It's not a technical act, it's a political act because it involves trade-offs all the way around. You have to make sure that all the stakeholders are bought in to those trade-offs. Now, for the purpose of this class, your architecture document can be as simple as, hey, here's an overall diagram of what we're building. But keep these issues in mind as you're doing that, because to the extent that you defer thinking about some of these issues, they will come up and bite you later. SAI talks about an architecture process. Go look at the slide later. I'll post this. Now, design are your specific solutions to implementing architecture. So you have this big diagram. Here are modules. Here are so on and so forth. Okay, for design patterns, okay, how do these two modules talk to each other? What's the specific API? What's the specific communications mechanism? You know, are they remote? Is this going over the internet? Is it a remote procedure call? Are they living in the same memory space? What are the patterns? So you have actual design patterns, design reuse. The goal of your design effort is to maintain the conceptual unity that the architecture should reflect. Meaning that ideally you want to take design elements that are going to make sure that all the components talk to each other. Design covers user experience, user interface, database design, data structure design, patterns and module interfaces, deep interfaces. Okay, an API, application programming interface. You get a layout. Okay, here are all the calls that you can make and the parameters, and here's what each of these methods does, and so on. But your deep interface says, in order to accomplish X with this module or this object class or whatever, I first have to call this method, and then based on results, I then either call this method with these values or I call this method with these values. That's a deep interface. That's one that's not necessarily exposed by the API per se, but requires higher documentation to say, this is how you properly use this module, this object, or whatever. Coding standards and guidelines are, again, they're very useful. If you have more than one developer, they're very useful. Decision on use of specific tools, languages, libraries. I know a lot of you have had negotiations on it, like, okay, we're going to use this. We have a few people who know how to use this particular engine, or here's this language, you know. Some of us are good at it, others want to learn it, so let's go ahead and use this. These are all decisions. Now, a lot of methodologies have specific design deliverables that they want you to create. You know, classic, simple ones. Well, let's have a class diagram. You know, it's object-oriented development, and we have, you know, depending whether you have a root object class or whether that you've got no root object class. You know, here's how we develop it. Here are the hierarchies. Here's where the inheritance is, and so on. Suggested approach to your document. State the purpose of your product and the purpose of the document. Give the overall view of your system architecture, which is probably going to be one diagram. You're welcome to get more complex than that, but explain the divisions based on the team. Remember, architecture will reflect your communication patterns. So you want to organize a team to fit your architecture. Fill in details on how to allow implementation from the design. And this in particular, identify the hard problems up front. I would strongly suggest you put that in your design document. That's something I'm going to look for. As a team, sit down and say, what are the single hardest things that we're going to have to figure out in order to accomplish this? Either we don't know how to do it, or we know basically how to code it, but this is going to take more effort than anything else. There are, and this should be on your wiki by Saturday at midnight. Again, you'll have a chance for refinement and so on, but you need a first cut this week. This is where you're going to probably earn your 7 hours of billable time each this week. There are existing documents out there on the old wiki. Feel free to grab one, you know, file off the serial numbers, use the same format. Again, have we talked in here about software reuse yet? I know I've talked some. Software reuse was this big, well, we talked some in Brooks because it was one of the silver bullets that he brought up, and that didn't pan out. Software reuse was the big mantra in the 90s, particularly in connection with object-oriented development. We're going to build all these reusable objects, and then we just build software by putting all the reusable objects together. And it largely was a doomed effort. I was in the middle of that because I was at Fannie Mae and I was mentoring their in-house reuse team. The biggest reuse we got were out of scripts, shell scripts. Once you have a working shell script, it's like, oh yeah, we can do this all day long. The effort to try and design reusable objects from an object-oriented sense ran into trouble big time, because the more general and thus in theory reusable an object it is, the less suited it is to any particular application. That's a trade-off you work at. The other major area of reuse where reuse is really effective is, frankly, in your deliverable documents. You know, if you find a format for design or for architecture or for PERT or whatever that you like, reuse it forever. So I have absolutely no problem. Go out to the winter 2017 wiki. In fact, if you keep changing, you can probably find previous years as well. Feel free to grab the document from there. Use that as your format so you're not spending time trying to think, how should this be organized? Figure anything out on the winter 2017 wiki is stuff that got a good grade. So, you know, look at it, find what you like, and delete all of their content and put your own content in. Because this isn't a class on coming up with the best design for an architecture design document. It's content that I'm concerned about. Any questions on this? No? Okay, you guys got a full hour here.